Hi there, welcome to highschoolmaths.co.uk. Today we're going to be looking at how to find the volume of triangular prisms. Now triangular prisms, quite a straightforward shape. What you're doing, or what you've got, is basically just half of a cuboid. Okay, so if you remember, the volume of a cuboid was length times breadth times height. If a triangular prism is half that, then the volume formula for a triangular prism is a half times length times breadth times height. So if we look at the shape we've got here, it's V equals a half times the length times the breadth times the height. You're multiplying the dimensions, so it doesn't really matter which order they come in. Just to make sure you pick the correct 3 dimensions from the shape. There's only 3 here, so no mistakes to be made. So half times 4 times 9 for the front face, times the height of the shape, or how far back the shape's been pushed, times 10. And if you type that into your calculator, we should get 180 cubic centimeters. Remember, those units are cubic centimeters because it's a volume. Okay, next question. Same type of shape, it's still a triangular prism. It looks a little bit different, but like all shapes, if you turn them around or rotate them, they can look quite different from what you're used to seeing. But it's still a triangle at the front, and it's that kind of cross-section shape, that triangle shape all the way through. So it's a triangular prism. Okay, so same formula. V equals a half LBH, a half times the length. I'm going to do the front face first again, so 5 times 14 times how far back it's pushed, which is 7. And again, just type that into your calculator. 5 times 14, sorry, a half times 5 times 14 times 7. Let's see what we get. That's 245 cubic centimeters. Okay, exact same working as the previous question, just a slightly different looking triangular prism. One of the most common triangular prisms you'll see in real life is the Toblerone shape. So if you that's a triangular prism in a real life context, and it looks very different from these shapes here. I suppose kind of similar to this one, but it's a lot longer in terms of the height, or how far back the triangle part goes. Last one we're going to look at is combining what we've looked at in the cuboid and the triangular prism to make a composite shape. So if you look at what we've got here, this front shape, we don't know a specific formula for that. What we're going to do instead is split it into 2 shapes that we recognise. And that's what you've got to do with these composite shape questions. You've got to look for the shapes that you actually recognise. We're going to take a straight line, and let's make it a dotted straight line. We're going to split into a cuboid on this side and a triangular prism on this side. And I'm labelling them 1 and 2 just to keep my working nice and neat. So we're going to start off with 1, and that's a cuboid, which is just length times breadth times height. So V equals L times B times H, or LBH. Careful when you're picking the dimensions. I'm going to highlight the ones we need. So looking at the front face again, it's length times breadth times height. Those are your 3 dimensions that you've got to pick. Okay, so we're looking at 12 times 10 times how far back. Now if you look here, it's not given a dimension, but if you look elsewhere in the shape, it's 8 centimeters deep, so times 8. And sometimes you will have to look elsewhere in the shape to get your answer. That should give you 960 if you type that into the calculator, cubic centimeters. Now that's just for the cuboid, that's just for shape 1. We've got another shape, shape 2. And you could have shape 3 and 4 if it was quite a big shape, quite a big composite shape, but we've only got 2 here. Now, it's a triangular prism, so it does have a different formula. It's a half LBH, like we just saw. So it's a half times. Now, I'm going to highlight again, just in a different colour here. So looking at the front face first, the length times the breadth. Be careful with the breadth, it's not this sloping line here, it's the height, the kind of height of the triangle at right angles to the length. And here, we've got our height, or how far back the shape goes. So those are our 3 dimensions we want to pick out. First one, not too bad, that's 10 from across here. So half times 10 times this part here. Well, we're not given that. What we're told is that the whole shape is 15. And this part was 12. So 15 take away 12 must leave 3 centimeters for that part there. So half times 10 times 3. And the height, or how far back the shape's going, 8. Again, just type that into your calculator. That should give you 120 cubic centimeters. That's not you finished there. You've calculated the two individual shapes. You've got to add them together now. So the total would be 960 add 120, which is going to give you 1080 cubic centimeters for your total volume of that shape. That's how you look at volume of a triangular prism, and a little example of how it can mix with your composite shapes. Hopefully you found it useful, and if you did find it useful, please don't forget to click the like button and subscribe, and remember to share the video. Thanks for watching, and have a mathemagical day.